In this video, I'm going to address the question, what is HLM and why do we use it? HLM is used to model nested or clustered data, where data on lower level observational units are nested or clustered within higher level units. For example, students are nested within classrooms or teachers, and classrooms or teachers are nested within schools. Schools are nested within districts, and so forth. Similarly, repeated measurements on an outcome variable may be nested within person, or some other higher level unit such as organization. So let's start with an example. Let's say that I'm interested in identifying predictors of variation in student achievement. Student achievement, as well as other individual differences factors such as motivation to learn, gender identification, and prior knowledge, may be conceptualized as falling at the lowest level, or level 1, of a nesting structure. In addition to modeling level 1 predictors of achievement, I might also consider contextual factors associated with the nesting structure that may predict achievement. Given that students are generally nested within teachers, I might be inclined to test whether teacher characteristics, such as teacher motivation to teach, may account for variation in student achievement. Moreover, given that teachers are nested within schools, I could extend the model to take into account school-related characteristics that influence student achievement, in part via their influence on teacher characteristics. So you can see right here we have nested data with students nested within teachers nested within schools. So student level data, the measurement of achievement, prior knowledge, gender identification, and student motivation to learn would all be falling at level 1 of this hierarchy. The teacher characteristics such as teacher motivation to teach would be falling at level 2. And then whatever school related characteristics would be falling at level 3. So here we have a situation where each student is measured on achievement at level 1 and perhaps one or more predictors. Again, this might be gender identification, prior knowledge, or motivation to learn. So the students are considered as being nested within teacher. So this nesting structure, if we're using OLS or least squares regression, can produce violations of the independence assumption, specifically violation of residuals in that model. And so the violation of independence then can result in bias standard errors, which in turn, when we're testing the regression coefficients in least squares regression, we can end up incorrectly rejecting the null and inferring a population relationship when perhaps there's not one. So one reason why we might utilize HLM is to reduce or eliminate biases and standard errors and decrease the likelihood of committing type 1 error when we are testing the regression parameters at level 1. So in other words, even if we're not interested in the contextual factors per se that may impact student achievement at level 1, one reason why we might utilize HLM is to essentially adjust the standard errors and reduce biases when it comes to testing the regression coefficients at level 1. Reason 2, HLM allows researchers to model contextual predictors of variation in lower level outcomes. So in other words, previously we weren't really considering the issue of why there might be between teacher variation in student outcomes such as achievement. We were just taking into account that that the average level of student achievement may vary across teachers, and that's it. And so, but we might also be interested in determining whether the variation in student achievement across teachers might be a function of certain teacher characteristics. So this is where the contextual predictors come into play. So here we're considering the possibility that level of teacher motivation, which is a characteristic of each teacher, may account for variation in students' level of achievement. One way historically of relating contextual factors such as teacher characteristics to lower level outcomes, that is student characteristics, is through a process called disaggregation. And that basically entails assigning each lower level unit the same value on a characteristic associated with a higher level unit. For this example, one might assign all students nested within teacher 1 the same value on motivation to teach for that teacher. Those nested within teacher 2 would receive the same value, and so forth. So if I have a data file that's set up with student level data, where each row would contain the student measures of achievement or motivation to teach, or excuse me, motivation to learn, or gender, or whatever. We would also have, if we're using this process of disaggregation, we would also have a variable associated with each student, which would reflect the level of teacher motivation. So in other words, all students who fall under teacher 1 would receive the same value on teacher motivation as that teacher. All the students within teacher 2 would receive the same value, and so forth. So disaggregation, though, is problematic as it produces conceptual and statistical problems. Conceptually, you're treating contextual characteristics from a higher level of the nesting structure as if they're characteristics of the individual. So it doesn't really make sense to include teacher motivation as a student level predictor of student achievement. So that's a conceptual problem right there. And statistically, this doesn't actually eliminate the problem of correlated errors due to the nested structure of the data. Now, a second strategy has been to aggregate data from lower level units to upper level units. So in other words, rather than the process of disaggregating to the student level, we aggregate the student level data up to the teacher level data. So for example, if we were studying the relationship between teacher motivation and student achievement, I might compute a mean achievement score for the students within each teacher and then use those classroom or teacher means as outcomes of teacher level characteristics such as teacher motivation. This is problematic as well. First, relationships between variables can differ at different parts of the data hierarchy. So let's say, for instance, I was going to aggregate the student level data. I wanted to include teacher motivation as a predictor of student achievement, and then I also wanted to include student predictors or student level predictors such as prior knowledge or motivation to learn as predictors as well. So I might compute class means on those variables as well and include those along with teacher motivation as a predictor of the classroom mean or teacher mean for student achievement. And what I'm basically saying is that the relationships that occur among those variables at level 1 involving, say, prior knowledge or motivation to learn would not necessarily hold up or behave in the same way if we aggregate that data to level 2. So that can be a problem. We also have, just the interpretive problem with if we aggregate to level 2, then we're not looking at variation in the individual levels of achievement. We're losing all that individual level variation within teacher because we're taking the teacher or class means and moving them up to level 2. Also, from a practical standpoint, we lose sample size. So instead of having sample size be dependent on the student level data, which, when it comes to testing statistical significance, our N is going to be much greater at level 1 than at level 2, because at level 2, the sample size depends on the number of teachers, not on the number of students. So we also have a loss of statistical power if we were testing hypotheses concerning the relationship between teacher characteristics and our teacher motivation and let's say class averages for student achievement. So HLM provides a viable alternative to using aggregation or disaggregation, as it allows researchers to adjust standard errors for nested effects while at the same time providing an avenue for properly attributing variation in the level 1 outcome, both individual level and contextual processes. In addition, it may be the case that relationships between variables at a lower level of the data hierarchy may vary across higher level units. For example, let's say we wish to predict variation in student achievement as a function of both student motivation and teacher motivation. It may be the case that the relationship between student motivation and achievement varies across teachers who themselves have varying levels of motivation. So this is kind of an example of what I'm talking about. Let's say I don't know what the actual relationships would be, so I'm just kind of spitballing here. But let's say that we're interested in looking at the relationship between student motivation and achievement. So let's say that among low motivation teachers, we might have a very strong relationship. In general, among low motivation teachers, the intercept would be low, so we'd expect a low achievement level among low motivation teachers. But then maybe as motivation on student achievement increases, we also have increasing levels of achievement. Intermediate level motivation teachers, maybe the slope for the relationship looks like this. And you can also see that maybe if you look at the intercept, which is sort of an adjusted class mean, be a little bit higher. You would kind of expect that. And then among high motivation teachers, you can see the intercept would be a little bit higher, and maybe the slope sort of flattens out a little bit more. So, it could be that the slope among low motivation teachers is particularly pronounced, whereas maybe slope begins to decrease a little bit as you move from low motivation teachers to higher motivation teachers. And this is reflecting the notion of a cross-level interaction, where basically level 2 characteristic associated with the teachers is moderating the relationship at level 1 between student motivation and achievement. Repeated measures data can also be considered as nested, as measurement occasions of the same observational unit are nested within each unit. Moreover, because of the incorporation of a time component, we are more likely to have correlated observations due to a carryover from one measurement occasion to the next. For example, let's say we're measuring teachers' motivation to teach across 3 time points during the school year. This is an effort to better understand how motivation rises and falls. In addition to measuring teacher motivation, we might also measure perceived stress at each of those time points. So you can see right here that the measurement of teacher motivation and stress occurs at times 1, 2, and 3 for each teacher. And so those measurements are nested within teacher. So in effect, we look at perceived stress as a time varying covariate of the level 1 outcome, being teacher motivation. So, and like I said, basically, you could think about it as there may be carryover effects from one time to another when it comes to measuring the outcome variable teacher motivation and perceived stress. Additionally, we can incorporate the possibility that teacher level characteristics such as coping strategies can moderate the relationship between perceived stress and teacher motivation. So in other words, again, we model a cross-level interaction between the level 2 unit, which is essentially teacher and whatever characteristics, and this is coping strategy level, and the level 1 relationship between perceived stress and teacher motivation. So here's an example. So if we associate at level 2 coping strategies, some teachers have higher levels of coping strategies than others, then we could, it may be that the slope depicting the relationship between stress and motivation varies across teachers who have different levels of coping strategies. So here we have, really in all cases, the slope is negative when it comes to really quickly, I just changed this out because it didn't make a whole lot of sense. But basically, if you think about perceived stress, this is probably theoretically a little bit more in tune with what we would expect. So if you can imagine teachers with low coping strategies, probably they might have lower motivation to teach in general, but then as stress gets higher and higher, you have some decrease in that stress level. Whereas teachers with intermediate level coping strategies, maybe they, at low stress, maybe they have a little bit higher motivation, and then, the stress kind of also reduces. As stress increases, there's a reduction in motivation. And then perhaps teachers with high coping strategies, you would expect that at low levels of stress, they have higher levels of motivation, and the effects of stress would be less pronounced than what you would see among teachers with low and intermediate level coping strategies. So at any rate, this is, like I said, this is probably maybe a little bit more consistent with what we would expect. Also, keep in mind that HLM models are also called random coefficient models, and so that's because to model lower level outcomes as a function of higher level factors or predictors requires allowing the coefficients that we typically assumed as fixed within standard least squares regression to randomly vary across higher level units. For example, consider the equation for a simple regression where you have each predicted score on y, the dependent variable or criterion variable, equals, and this is the intercept. So this is the predicted value on y when your predictor variables are set to 0, plus the regression coefficient for predictor x. And so basically we're multiplying each the regression coefficient times each person's score on the predictor x plus residual. So in other words, it's the essentially prediction error within the model. So each, if this is, if we're looking at individuals, scores on y as a function of x, you could say that each person's score on y is partially a function of the intercept plus the regression coefficient times each person's score on x plus a certain amount of prediction error. And so within HLM models where we allow our coefficients to randomly vary, we can say then that we can allow the intercept and the slope to randomly vary across level 2 units or higher level units. So kind of going back to the example with our teachers, low motivation teachers, intermediate and high motivation teachers, and looking at the slopes being depicted by B1, and the J is reflecting the teacher at level 2, or the classroom or teacher at level 2. So you can see we've got random variation in slopes. And so theoretically, we would have a larger number of teachers than just 3. We would have teachers that reflect varying levels of motivation, and we would have within each of those teachers the students, and then the slopes for the relationships between student motivation and achievement varies across teachers that exhibit varying levels of motivation. We also have the B0J, and that's reflecting the intercept for the regression line within each teacher. So you can see and basically the intercept is an adjusted mean. So in other words, it's the mean on achievement adjusted for the presence of our predictor in the model. So you could look at these as basically kind of essentially adjusted classroom or teacher means. And so you can see that among low motivation teachers, you would expect the intercept perhaps to be for achievement to be lower than the intercept for intermediate or high motivation teachers. So in a nutshell, with HLM, we can build in the ability to randomly vary the intercept and or the slope, and that's what allows us then to study the relationship between higher level units and the characteristics of those units and lower level outcome variables. So at any rate, that concludes this introduction to HLM, and hopefully this provides a good explanation of what HLM is and why we would use it.